Hi guys. So I'm gonna do my best, so bear with me. Okay. Today we're gonna start with 3-3, which is on page 156. So excuse me. And no judgment, right? Because we're tight like that. Okay. So, solving and graphing systems of linear equalities. This is the same thing as what we were doing last chapter when we just graphed the linear equalities on their own. So, example 1 says to take y is less than x plus 2, and then also, this is on page 157, to take y is greater than or equal to, let's see if I can move this closer. There. Y is greater than or equal to negative 3x minus 1. So, to do this problem, all you have to do is graph these. And it's exactly the same as when we were graphing them one at a time like before. So to graph our first one, y is less than x plus 2. Our y-intercept is 2. And because there's no coefficient in front of the x, that means that the slope is 1. So, over 1 and up 1. So that, and then we connect and we use a dotted line because it's not less than or equal to, it's just less than. And then because it is less than, all of our y's are under that. So, like that. And then to graph our second equation, y is greater than or equal to negative 3x minus 1. So negative 1 is our intercept, and then our slope is negative 3. So if we go up 3, 1, 2, 3, we need to go negative x for the 1. And because it is greater than or equal to, we can graph it with a solid line. Okay? And greater than means all the y's are going to be above that line. So here. So our solution for the problem is where these regions overlap. So you can see that's right there. And that's all there is to it. I'm just gonna have a sip of Perrier real fast. Okay. So, if you are asked to find a solution, the solution is this entire area. So, when it comes to using coordinates, any coordinate in this region is a solution. So like here, I can see that the origin, the point 0, 0, is in the shaded region. So if the problem, like numbers 15 through 20, asks you to give an ordered pair that is a solution, you would just pick a coordinate that's in that shaded region. So the point 0, 0 works fine there. Okay, I think that's all you're going to need for 3, 3, because this is just doing 2 at the same time or more, but they won't be very difficult. Just remember that if you have an equation that looks like this, that's a vertical line. And if you have an equation that looks like this, that's a horizontal line. And don't forget to look and see whether or not the line is included in your solutions. If it's just a less than or a greater than, you need to use a dashed line. If it's less than or equal to or greater than or equal to, you can use a solid line. And that's it for 3, 3. So let's move on to 3, 4, which is called linear programming. Let's see. Okay. Mrs. Peterson is sick. So, let's see. Linear programming has to do with almost all word problems. But because we're just introducing this concept to you, you will not be asked to do all word problems. Linear programming is made up of an objective function, and constraints. Pretty much what linear programming is for is real life situations where you want to find out how you can combine certain things to maximize something like profit. Like if you're making 2 different kinds of candy and they cost a different amount to make and to sell, and you want to find out how many should I sell of each to make the most amount of money. So that's what linear programming is for. So the constraints have to do with the criteria, the conditions of what you're working with. So that would be things like this. X is greater than or equal to 0. They're the conditions that you have to meet. So, and then you might have something like, if you're making candy, you only have 10 pounds of sugar. And so if X is your pounds of sugar, X has to be less than or equal to 10. Things like that. And we're going to do an actual example. I'm just explaining the parts to you right now. And then our objective function would be the actual point of the whole problem. The function that's about what we're really looking for along the way with all these steps. So that would be something like our profit equals like pounds of sugar, and we sell that candy for, I don't know, like 5, and then plus like 6y. Something like this. So this linear programming is a combination of graphing linear inequalities like you're doing in 3, 3, and plugging things into linear equations and just checking for the answer. So that's all there is to it, and it's only going to be in this one section. So even though there are a lot of steps for a word problem, you've already done every single step in some other kind of problem. So let's do an example. Okay, so the example is on page 165, and it's example 3. It says, 2 manufacturing plants make the same kind of bicycle. Okay, so the table gives hours of general labor, machine time, and technical labor required to make one bicycle in each plant. So there's plant A and plant B, and then the different kinds of labor are general labor, machine labor, and technical labor. Tech. Okay, so it says hours per bicycle in each plant. So of general labor, plant A takes 10 hours for one bicycle. For general labor for plant B, it takes 1 hour for each bicycle. For machine time, plant A uses 1 hour per bicycle, and plant B uses 3 hours per bicycle. For technical labor, plant A uses 5 hours, and plant B uses 2 hours. Okay? Ow. So it says, for the 2 plants combined, the manufacturer can afford up to 4,000 hours. So 4,000 hours of general labor, up to 1,500 hours of machine time, and up to 2,300 hours for technical labor. Okay. Plant A earns $60 per bicycle. So this is $60 per bicycle. And plant B earns $50 per bicycle. Okay. So then we want to find out how many bicycles plant A should make and how many bicycles plant B should make so that we make the most amount of money. Okay. So we know that however many bicycles we make, it has to be greater than 0. Or it could be 0, but 0 or greater. So let's call X plant A bicycles and Y plant B bicycles. So we already know, and now we're moving into our constraints. We already know X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Okay, so what else do we know? what other equations can we make? Well, we know that for plant A, they use 10 hours per bicycle of general labor, and plant B uses 1, but that if we add them together, it can't be bigger than 4,000. So 10x plus 1y has to be less than or equal to 4,000, because it can't be bigger than that. And then for machine labor, for machine time, so 1 and 3, but when we add them together, can't be bigger than 1,500. And just as a reminder, the x and the y represent how many bicycles each one is making. So if we multiply x times 1, that's how many machine time hours plant A uses to make x bicycles. So x plus 3y must be less than or equal to 1,500. And then lastly, for our technical labor, 5x, can you see the bottom? Yeah. 5x plus 2y must be less than or equal to 2,300. Okay, but now what about this information about how much we're going to sell them for? Because here, this is all just about us manufacturing them. What we know about what we can do. Now we want to figure out what we should do. And that represents our objective function. Because that's the main thing, that's the whole reason we're doing all of this. We want our profit to be as high as possible, and our profit is $60 per bicycle from plant A, so that's X, plus $50 per bicycle for plant B, which is Y. Okay, so this is the hard part, and that wasn't so bad, right? So now what you need to do is graph it. These numbers are pretty big, so I'm just going to show you how to graph them and then copy the graph out of the book. As your examples or your problems, don't use numbers that are that large, so it'll be a lot easier to graph. Okay, so we're just going to graph them by solving for y. So this one, let's use a different color. Let's get folly up in here. So we're just going to solve for y. So y is less than or equal to negative 10x plus 4,000. Because we just moved our x to the other side by subtracting. And then here, we need to move our x by subtracting, but then to solve for y, we have to divide everything by 3. So we'll get y is less than or equal to, I subtracted x, so it's negative, and I divided by 3, so it's 1/3, plus 1,500. And then here, I need to subtract my 5x to the other side, and then divide everything by 2, because it's 2y. So that's going to be y less than or equal to, it was negative because we subtracted it, and it was 5x, but we had to divide it by 2. So negative 5/2 x, and then plus, oops, I didn't divide 1,500 by 3. Now I did, because there was a 3 in front of the y, so I needed to divide everything by 3. So then y is less than or equal to negative 5/2 x plus 2,300 divided by 2. So that's 1150. Now, so all of here, this is my y-intercept, and my slope is negative 10. So this is 500, that's my y-intercept. My slope is negative 1/3. And then here, negative 5/2 is my slope, and 1150 is my y-intercept. So, when I end up graphing this bad boy, let's see, the 500, you would graph them one at a time, and you're not going to have numbers this big. So let me emphasize that you graph them the normal way. So we would have 4,000, and then we would have that be decreasing by 10. So it comes down like this. Okay, and that's our equation, or inequality 1. Inequality 2 would come in at 500, right there. And it would be decreasing by 1/3. So a slope that's nowhere near as steep. And then this one, our y-intercept is 1150. And then it's negative 5/2. So what ends up happening, you find the shaded region. Like, they're all going to overlap, and the shaded region will form a shape. So I didn't graph this very exactly, but it should have 4 corners to the shape. 1, 2. Let's pretend this pink one came down like that. So there should be another one here. Please bear with me. I'm so sorry. I hope this isn't confusing. There are 4 corners, and the corners have to do with the shape that is made by the overlapping regions. So we find the coordinates of those corners. So this one is 0, 500. This one here. And you'll be able to see what the coordinates are on your graph paper. I'm just taking this straight out of the book. So 300, 400. This coordinate here is 380, 200. Roman! Stop licking. Sorry. A dog. And then 400, 0. Okay. So all of these represent x, y's that work for all of these equations, all of these constraints. And those x, y's are what we're going to plug in here. So, one, 2, 3, 4. I'm going to have 4. So profit 1 is from 60 times 0 plus 500, or 50, times 500. So, I don't have a calculator up here. That was responsible. Okay. So that comes out to be 25,000. Profit 2 is these 2 x coordinates here, 300 and 400. So 60 times 300 plus 50 times 400. So 60 times 300 is 18,000. 50 times 400 is 20,000. So if we add them together, that's 38,000. Profit 3 is from right here, 380 and 200. So I have 60 times 380 plus 50 times 200. And that's going to equal, see, 6 times 38. Okay, 6 times 8 is 48. Carry my 4. 6 times 3, so 22,800. And this one is going to be 20,000. No, 10,000. I'm sorry. So 22,800 and 10,000 is 32,800. And then our profit 4 is from these two coordinates here, 400 and 0. So you have 60 times 400 plus 50 times 0, which equals 24,000. So, my possible profits are those four. Which one's the biggest? 38,000. And what coordinates did I use to get a profit of 38,000? This one, 300, 400. That's the answer. I should make 300 X's, which were bicycles from Plant A, and 400 Y's, which were the bicycles out of Plant B. And that's how to do it. That's it. So, your homework is going to be asking you to find the minimum and maximum values for each region. You're going to be plugging them into the objective function, which is the function that they give you. It's usually labeled objective function, but that's the actual equation. So like in number 9, it says C equals X minus Y, and then there's a graph where you can see they've graphed inequalities and shaded in a region, and it made a shape. So you're just going to find the coordinates of the corners of that shape, which they even give you, 0, 0, 0, 40, 30, 30, and 40, 0. Plug each one of those combinations in. You'll get 4 different C's, and the biggest one is your answer for maximum. The smallest one is your answer for the minimum. And that's all there is to it. And then for numbers 12 through 20, you have to graph it yourself and then shade it in appropriately and find those corners. But that's it. And then you only have 1 word problem. Maybe 2. I don't remember. I'm going to post your assignment in like the about this video. So if you need any help with it, just ask me, because I'm here for you. Thank you for bearing with me, and I hope that this makes sense and you're good with this. We'll, of course, go over our homework problems on Thursday before we get into our new material, which is... I'm just going to wait till Thursday to tell you because it's super fun and exciting. But then next week is, next week is your test. We went through chapter 3 super fast. That's it. So, okay. I think you're all great. I love my students. Okay, bye.